Okay, we're going to finish this problem and then we've got a couple more examples left. Okay, so if 1 gram is left, how old is the fossil? So we're trying to figure out the t value on this problem. So we know that there's 1 gram left. We know we started with 10 grams. And we know that the half-life is 5,730 years. So we're going to solve for t. That's a 1. Okay, so we need to isolate the exponent. So the first thing we need to do is divide by 10, get that out of there. I just want to make a note first. You cannot multiply 10 times 1/2 first and say that's 5 to the t divided by 5,730. That would not be following order of operations. Remember, parentheses, then exponents, then multiply. So you should not be multiplying these two numbers together. Instead, you divide out the 10. Okay, so we have 1/10 equals 1/2 to the t divided by 5,730. Now the exponent is isolated, so now we can swoop it into a log. It's going to look a little weird, but it'll work. Log base 1/2 of 1/10 equals t divided by 5,730. So type this in your calculator. Log base 1/2 of 1/10. Type that in your calculator and see if you get what I get. Okay, so I got 3.322 equals t divided by 5,730. So now if I want t alone, I'm going to multiply by 5,730. And I get 19,034.65 years. So that's how old the fossil is. Okay? All right, next problem. All right, now we haven't done one of these yet. That's better. Okay, we haven't done one of these yet. So what we're going to do is we're going to find the model. This is the exponential model that fits these 2 points. Okay, so these are just xy points. So you can plug 0 in for x and you can plug a 2 in for y. Let's see what happens when we do that. Plug a 2 in for y and plug a 0 in for x. Okay, well, up in the exponent, b times 0 is 0. What's e to the 0? E to the 0 is 1. So therefore, a equals 2. All right, well now let's use the other point and plug it in for x and y. So plug a 1 in for y and plug a 5 in for x. Well, now on the previous problem, we found that a was 2, so we can actually plug a 2 in for a as well. And instead of b times 5, I'm going to say 5b. Well, we can solve for b. So let's divide by 2. And it's an exponent, so we're going to swoop it into a log. Log base e of 1/2 equals 5b. If you want to say natural log of 1/2, go right ahead. And to get b alone, we have to divide by 5. So natural log of 1/2 divided by 5 will give us the b value, and that ends up being negative 0.14. So now you take the a and the b and you put them back together in this formula. So y equals 2e to the negative 0.14 x. And that would be the model, the exponential model, that goes through those 2 points. Okay. Last example, I think we'll do this last. Yeah, this will be our last example. Okay. The population in thousands of Colorado Springs is given by that equation, where t equals 0 represents 2,000. In 1980, the population was 215,000. Find the value of k and use the result to predict the population in the year 2020. All right, we got to use this information. In 1980, the population was 215,000. What would t be in 1980? If t was 0 in 2000, what's t back in 1980? So it's like going backwards in time, right? That's 20 years before the year 2000, so t would be negative 20. So when t is negative 20, our population p is 215,000. Plug that stuff in. Oh, and I should say, forgot about this, the population p is in thousands. So we don't need to write 215,000, we can just write 215 because it says it's in thousands. So 215 equals 361 e to the k, which we're going to find, times t, which is negative 20. Okay, now we're going to divide by 361. Okay, 215 divided by 361 is 0.5956 e to the negative 20. Okay, now we're going to solve for the exponent. So we're going to swoop it into a logarithm. Log base e of that decimal, 0.5956, equals negative 20k. And if you want to say natural log, you can. So type in natural log of that decimal, and you get negative 0.51824 equals negative 20k. And to get k alone, we're going to divide by negative 20. So I'm getting 0.0259. Okay, now that's the value of k. We're supposed to use the result to predict the population in the year 2020. What's time in 2020? If 0 is 2000, then 2020 would be 20. So now we're going to use that k value up in the equation, and we're going to find the population in the year 20. So 361 e to the, plug this in for k, times t, which is 20. Okay, so type that in your calculator. Okay, so I'm getting 606.14 about. Now, depending on how you rounded, if you rounded this to 0.026, you would have gotten 607.2. But now, just remember, what is your answer representing? Your answer is the population in thousands. So this is 606,000 people. It's not 606 people, it's 606,000 people. Please be careful of your units, because if you leave the thousand off, 606 people is way different. So just be very careful about your units. Okay, I think we're gonna stop there. So now what you're gonna do is start working on your homework, and on Monday we'll go over your questions. I'm sure there's gonna be questions. But start your homework, and I'll see you on Monday. Okay, bye.